Okay, hello again. We're going to be talking about Chapter 4 now, and Chapter 4 deals with global climate change. And this is one of these issues that has become very political, and so there's all kinds of misinformation out there. But if you really understand what is driving the rise in global temperature, there's no argument against it. So, so your book starts out with a scenario that talks about a situation where we have all kinds of global conditions, tornadoes and horrible storms. All of this kind of stuff is going on. It's talking about sea level rise, a large amount of sea level rise, let's say. So the scenario number one that they talk about is a 6 degrees centigrade temperature rise. Now, centigrade is 1.8 degrees, so we're talking about 10 degrees, approximately 10 degrees Fahrenheit rise in temperature. And it talks about how, we have heat waves, and we're seeing some of this, like Australia was burning up all last year. Horrible tornadoes, horrible storms, all of this kind of stuff. Water shortages, because we're going to change the global distribution of water, all kinds of terrible things. And that's one scenario. And then there's another scenario which says that glaciers that were lost in the 2000s, the early 2000s, are reforming, and places that were flooding due to global warming are becoming habitable again. The good side. And so the bottom line is, what is going on? What is driving global climate change? And I want to show a graph. I've drawn it on the board. It's in your textbook. I don't know. I pulled it off of a graph from NASA. But anyway, NASA has been studying climate, National Atmospheric and Space Administration. So they're all about the atmosphere. So NASA has been studying climate for a long time, and they've figured out, scientists are pretty good at figuring out ways to answer difficult questions, like how much carbon dioxide was in the atmosphere 800,000 years ago. That seems like an impossible question, but it's not. There are places on the Earth where the ice sheet is so thick that the tiny air bubbles that are in the ice, if you drill deep enough, are samples of the atmosphere from thousands of years ago. And so we have these tiny bubbles to analyze going back 800,000 years. And here is what the graph looks like. So 800,000 years ago, the carbon dioxide parts per million, remember we were talking about it's about 400. That was what we were saying in the previous section. We're going to talk about how it's at 414 now, actually, as of May of this year. But historically, going back 800,000 years, CO2 levels ranged from down in the 200s up to 300 parts per million and back down. And so they fluctuated, but you can see they never went really above 300. And today, they have skyrocketed and have gone up to 414 parts per million as of a few months ago. Now, how is this possible? When we've talked about carbon a little bit already this semester, we've said that CO2 from the atmosphere is captured by plants, and it's used to make plant tissue, and then when the plants are eaten, it becomes animal tissue. And then when a plant is burned or an animal dies and it decomposes, CO2 gas is returned to the atmosphere. So we have what we call a carbon cycle. And so this carbon is cycling back and forth in the atmosphere, and that's what was going on for close to 1 million years. Now, what are other sources of carbon? So if we think about carbon, we can say, oh, wait a minute, calcium carbonate, rock, coal, gasoline, natural gas. This is all carbon that's hidden away in the earth, not cycling between the atmosphere and life. And so what have we been doing? We burn fossil fuels. And so as we are pulling this carbon that has been hidden away for millions of years, as we're pulling it out of the ground and burning it, it starts cycling, just like the rest of it. It starts cycling in the atmosphere. So why do we see an increase in carbon dioxide? It's because we're adding it. We're adding carbon to the carbon that is cycling. And where is it coming from? It's this fossil carbon. It's being added to the carbon cycle, the carbon that is moving in and out of life. Now, why am I talking about CO2? Well, it is one of the gases, and we'll explore this in this chapter. It is one of the gases that captures heat from the sun. And so the more CO2 you have in the atmosphere, it's what we call a greenhouse gas. The more CO2 we have in the atmosphere, the hotter the Earth is going to become. And there are others. There are even some that are even more of a villain if we're worried about temperature rise. Methane is a gas that absorbs 25 times as much heat as CO2. It's also increasing in the atmosphere. So the carbon cycle is really important in this question of global climate change. Let me see if I have anything else. All right, I'll stop right here and maybe pick up on a point or two next time.